Do you remember this PC? Because I remember this PC. How could I forget this rig? This monstrosity is the system that Wifey Sauce and I put together for the Spicy Hot Wings Challenge. Watch that video if you happen to miss it. It's a classic. But you can see that I've brought the system back today because I've got an idea. I want to do a little experiment with this build. Today we're going to do something really stupid by removing every single fan in this system and see whether or not it can still function as a decent gaming PC without overheating or causing any other issues. Ordinarily, this wouldn't be a huge deal, but the fact that we're using high-end components that generate a lot of heat because they're very powerful makes this a serious challenge. We've got an AMD Ryzen 9 3900X 12-core 24-thread processor on an AMD B550 Tomahawk motherboard, along with 16 gigs of DDR4 FlareX memory from G.Skill at 3200 speed, and an RTX 2080 Super from MSI. This is their Gaming X Trio model. So clearly we've got our work cut out for us. I've already benchmarked the system. I ran Cinebench R20 along with 3 AAA titles, and so far the system's performing perfectly fine. Of course, I tested with the side panel on, and like I said, temperatures are really good right now, as they should be, because we've got a pretty beefy Darkrock Pro 4 cooler here from BitBoI that has not one but 2 fans. There's another fan in between these 2 heatsink towers, and we also have a number of case fans, 1, 2, and 3 140mm Pure Wings 2 fans. There's a lot of airflow running through the system right now, but in just a moment we're going to kill all of that and see what kind of temperatures we get under full load with a fully passive cooled system. Now, I'm already assuming that things are going to get a little toasty, maybe a little ugly even, so I've got a trick up my sleeve, which is undervolting. Yes, that's right. If we need to, which I'm assuming that we're going to at some point, I will be undervolting the CPU and GPU by any means necessary in order to bring our temperatures down to reasonable levels. I've actually already gone ahead and benchmarked this entire system so we can compare before and after removing the fans and undervolting to see whether or not all of this hassle is actually worth it. Now, for the record, as far as acoustics go, this is already a really quiet system, guys. It's incredibly quiet. Here, I'll move my lav. All right, so my lavalier mic is literally inches away from the system, and we're running Unigine Heaven 4.0. We've been running for about 30 minutes so far. So yeah, the system's already quiet to the point where, I mean, to be honest, going through the trouble of removing fans and stuff for this specific PC is totally not worth it in my opinion. The thermal impact we're gonna incur from removing the fans is not gonna be worth the slightly quieter operating noise because it's already so quiet. Really, this is just an experiment to see if we can do it and how undervolting could potentially allow us to run a dead silent system. Now, when building a really quiet PC, you typically see people use a silent case. By silent case, I mean a chassis that's got maybe closed off panels, right? Not a whole lot of ventilation. It's usually got some sound dampening material inside. All that stuff is designed to eliminate the noise coming from inside the PC. But since we don't have any fans in the system, I'm taking the opposite approach and instead going with a case that has ample ventilation all around, particularly at the front and top. This is the Pure-Base 500DX from BitBoI. And the idea here is that since we have a lot of mesh around the case, it'll be allowing air to sort of passively flow through the system as opposed to just creating a sort of hot box if we were to use an actual silent case. Apart from that, my methodology for this is really simple. Remove all the fans in the system. That includes the 3 case fans, the 2 CPU cooler fans, even the GPU fans. We've got a triple cooler design here. I'm gonna pop that off, just remove the entire fan shroud assembly. So it's just gonna be a massive heatsink on top of our GPU. That should be interesting. Since we can't practically remove the fan from the power supply, we're gonna be using a different PSU, which is over here, the Enermax DigiFanless 550 watt unit. This is a really old unit. I wish I had something that was more than 550 watts, but it's the only fanless PSU that I had on hand. I would typically recommend something higher than this for this particular system, maybe 650 to 700 watts, especially if you plan to overclock. But since we're just doing this for the video and I'm actually gonna be undervolting instead of the other way around, this should work for today. I've already gone ahead and benchmarked the system as is, of course with the side panel on, so that we have our before numbers, and then once I remove the fans and undervolt, I'll run all the same tests again, and we'll compare before and after removing the fans and undervolting to see whether or not we can pull off a passively cooled high-end gaming PC. Okay, we have done the unspeakable and removed every single fan in the system, and this is what we're working with right now. I just booted up for the first time. We haven't touched anything. No tweaking has been done, no undervolting whatsoever. We're completely stock settings on both our CPU And GPU, we're gonna look at our CPU first. We're gonna focus strictly on the 3900X. At idle, we're hitting a maximum temp of 75.8 degrees Celsius, which is obviously a red flag. I was gonna try running Cinebench to see what we spiked up to, but at this rate, I don't even wanna bother because I'd rather not torch my very expensive CPU right now. So this is obviously enough to let us know that we are in no condition to run this way, and we really need to spend some time undervolting if we want any sort of chance at running this system as is. A couple other things you should take note of here, just so we can sort of compare before and after we undervolt, is our clock speed. So right now we're hovering at around 3.725 gigahertz on all cores, and we've got a vid, well, the vid's kind of fluctuating obviously, but it looks like a maximum vid of 1.4, looks like 1.4 on several of the cores. So that's where we're at right now. Our XMP profiles have already been dialed in. We're at 3200 speed. So yeah, let's jump into the BIOS and start tweaking. So obviously there's many different ways to skin a cat, and by that I mean there's several different methodologies for undervolting your CPU. We're gonna take a look at just one example, one method for today, which is dialing in an all-core overclock and then trying to use the least amount of voltage possible in order to still maintain stability. So what's a good starting off point? How do I know if I should start at 4200 megahertz and work my way from there, or if I should start at something like 3700 megahertz? Where do you begin? Well, a good starting off point, in my opinion, is whatever the clock speed was that you were running at normally. So before I removed any of the fans, I ran Cinebench R20, and we were getting about 4,000 megahertz across all cores. So I'm gonna start at 4 gigahertz. So our CPU ratio is 40, and then we're gonna go down to CPU core voltage here, and we're gonna do override mode. And here I'm gonna pick a value that's somewhat close to the vid that I saw in hardware info, which I'm gonna say 1.1. We can always adjust this, of course. We're probably gonna have to. We're gonna either have to adjust the voltage or the clock speed, or both, as we go about this process. So let's just see if this works. All right, we booted into Windows, so we're at least stable enough to do that. But if you look at our idle temps, we're once again in the 70s. This is our maximum value, current, maximum, and average. So we're still getting really hot here. So hot to the point where it's not even worth trying to run Cinebench. We already know that it's gonna fail. It's gonna fail either by overheating, crashing, or all the above. So let's go back into the BIOS and retweak our settings. So for now, I'm gonna try keeping the 4 gigahertz overclock. I like that number. It's a bit of a long shot, but let's see how flexible we can be on our voltage here. So instead of 1.1, I'm gonna take this down 1.03. Oh, okay, so sometimes you don't exactly get the granularity you want, depending on which UEFI you have. Will sometimes lock you into certain increments. So here it says that the closest value I can get to that is 1.025. Let's give it a shot. And our system's not booting. So I kind of knew this would happen, but I wanted to show you guys what it potentially looks like when your clock speed is too aggressive and your voltage is too low. This is sort of the pinnacle of instability, is when your system won't even boot because there's just not enough juice flowing to your CPU, given the clock speed is trying to hit. So we're gonna have to clear our CMOS and try again. So I think at this point we can deduce that 4 gigahertz is just too aggressive with our cooling solution, because when we have enough voltage to make that overclock stable, we overheat. And when we dial that down to a place where we might actually have decent temps, well, then it becomes unstable. So we're gonna try, let's just try 3800. We'll start at 3.8 gigahertz, and we're gonna change our voltage once again to override mode. And this time let's try the same voltage that we tried with 4 gigahertz, 1.025. Now I guess it's worth noting that since we cleared our CMOS, our memory settings have been kicked off. We don't have an XMP profile set anymore, so I'll have to reconfigure that at some point, but we don't really need to do that right now until we're ready for benchmarking. All right, our idle temps have dropped significantly. We're hovering in the 40s now. We've taken off, what, 25, maybe 30 degrees off of the previous temperatures just by dropping 200 megahertz on all cores and lowering the voltage a bit. Of course, we're not quite as cool as we were when we had all the fans running in the system, but we're definitely low enough at this point to try running Cinebench to see A, if our overclock is stable, and B, if our load temperatures are adequate. So let's give it a shot. This is the all-core test. Multi-threaded test. Okay, test is complete. Max temp of 69.1 C. We didn't even break 70 degrees, guys. That's a huge improvement, and definitely something I'd feel comfortable running 24/7. Now at this point, we could either just say, okay, we're good, let's move on to the GPU, Or we could tweak this a little bit. Since we have a little bit of thermal headroom here, I've got one of two options. I could either try cranking up the clock speed a bit to see if we can milk any more performance out of our 3900X, or I can try lowering our temps further by keeping the same 3.8 gigahertz all-core overclock, but lowering our voltage so that we're at the lowest possible operating voltage while still remaining stable. So you know what? I'm gonna try chasing performance here. I'm gonna try bumping up our clock speed to 3.85 gigahertz. All right, just slightly. And I'm gonna see if that works with our current voltage value of 1.025. Okay, we've got a splash screen. All right, so we're at least stable enough to get into the operating system. That's a good sign, but let's see if we can actually run Cinebench. Moment of truth. Oh, and it failed. So we clearly don't have enough voltage. So at this point, we're at yet another fork in the road. We could either back down on our clock speed, going back to 3.8 gigahertz and work our way from there, or we can see how much voltage is required to get 3.85 gigahertz stable and see what kind of temperatures we get at that point. Let's give that a shot. So we'll keep 3850 megahertz. Let's just bump this up slightly, 1.0375. Let's give that a shot. All right, let's give it a whirl. Oh snap, it's looking good. We're at about 64C right now. Current vid is 0.975 and we're still at 65C, 66, 67. We're almost done here. Boom, look at that. So 67.4C at its hottest, which is very reasonable. Pretty much in line with where we were at 3.8 gigahertz with a slightly lower voltage, which is pretty impressive. And our score in Cinebench has actually gone up just a tick. I think it was around 6,800, it was closer to 6,800, now it's 6,841. Very slight bump in performance there, but hey, we're running 50 megahertz faster, temps are in check, this is good. You know, the fact that we haven't hit 70C yet kind of makes me want to shoot for 3.9. Should we try 3.9? Yeah, let's try 3.9. 3.9. Let's try 1.05. Sure, why not? Now I could have just left the voltage where it was and see if 1.0375 was stable for 3.9 gigahertz, but I have a feeling that it would not have been. Okay, 3.9 gigahertz at 1.05 volts. Let's see what happens. Oh. Not stable enough. So we know we need to increase our voltage, but by how much? That is the question. And will that amount cause us to overheat? Can we do 1.06? No, 1.07? Okay, so 1.0625 is the next increment that it allows us to input. We'll give that a shot. Okay, I have a hunch that this is gonna be stable, but that temps are gonna be a little close. 3.9 gigahertz at 1.0625 volts. Okay, it's looking stable, it's looking good, but we're definitely a little warmer now. 75C, 77, 78. Okay, so we were able to finish the test, and look at our performance went up quite a bit, 6,966 points. But now our temperatures are hitting 78.3 degrees Celsius at its hottest. So we really have to just sort of make that personal judgment call. Personally, I think I can sacrifice a little bit of performance, single-digit performance numbers for a lot better cooling, because this is significantly hotter. 78C, I mean, we were hitting what? This is a 10-degree increase, 10-degree increase in temperatures versus maybe, like I said, a single-digit performance gains. So I'm gonna go back to 3.8 gigahertz at that lower voltage, and that's gonna be where I lock in our CPU for today. Okay, I have returned from the BIOS and I dialed this back to 3.85 gigahertz and I configured our XMP profile, so we're at 3200 speed once again. We are now ready to do our final benchmark for comparison against the data that we got from when the system had all of its fans running at stock settings. So let's go ahead and run this guy and hope for the best. No, we crashed. Oh, we were so close. Okay, well, somehow we passed it the first time and failed the second time. That happens sometimes. So we have to go back into the BIOS and bump up our voltage slightly. Let's try 1.0415. Will it let me do that? Okay, it's too bad it doesn't let you do it in smaller increments. 1.047. Dang, so it's really gonna make me go 1.05. Okay, I guess we can try that. All right, here we go again. Okay, that's more like it. Max temp of 73C, perfectly acceptable, and a score of 6,918 points. So let's compare that against what the system scored with all its fans. 71C, so we only went up 2 degrees. That's hardly anything, so really good shape there. And as far as the score goes, performance-wise, we went from 7,255 points with all the fans to 6,918 points. Let me do some math really quick. We've only lost 4.6% of our performance. That's a relatively small single-digit loss that's not really going to be noticed in any capacity in real-world scenarios. So I'm perfectly happy with this result. I say we stick with it and move on to the graphics card. All right, so I've got Unigine Heaven 4.0 running in the background because we need to put a load on our system in order to start undervolting our GPU, which again is the RTX 2080 Super. But because there's no fans on the GPU, I can't really put a load on the system without the GPU skyrocketing to nearly 100 degrees Celsius. So I've actually put a couple case fans on our GPU just for the time being so that we can actually go about undervolting without the GPU turning into molten lava. And still, we're hitting 87 degrees Celsius right now with a maximum of 90 C. So we definitely want to try to undervolt this quickly before things stay toasty for too long. But here I have MSI Afterburner. Once you have that open, you hit Control F and that opens your voltage frequency curve. And from here you can start editing the curve. So basically these points represent your voltage and frequency. You've got frequency on the left on the y-axis and voltage measured in millivolts on your x-axis. And basically the way you want to do this, the way that I approach it, again, there's various methodologies here too, but the way that I'm going to do it is I'm going to sort of see where things plateau, like sort of where things flatten out, where the curve flattens, starts right about here. So you can click on that point and it'll tell you your voltage and frequency ratio, which is 1860 megahertz at 1037 millivolts. So we know that this particular GPU can run this frequency at that voltage stably. So to undervolt, I'm basically going to pick a point. Let's just say we'll start modestly, maybe at 950 millivolts. I'll start at the 950 millivolts point, and I'm going to click and drag that up to 1860 megahertz, which is again where our curve flattens. So once I've dragged that up, sometimes you can't quite get it exactly, so it's 1859 here. So I'm just going to stay at 1859, and once I've done that, I'm going to click apply within the MSI Afterburner window, and you'll notice that it brings all of the other points to the right of it up, essentially flattening the rest of the curve. And sometimes it'll bring your value down a little bit, like I had set it to 1860, but here it is at 1845. That's what the software is deemed appropriate. So now we're running at 1845 megahertz at 950 millivolts. And if we check our temperatures, nothing's changed, which is unfortunate. This is definitely due to the fact that we don't have proper cooling on our GPU. So far, undervolting has not really helped us in the thermal department, so we can continue down this road and try going for a lower voltage. So I'm gonna go with 925 millivolts at 1845, thereabouts. Apply. Now, obviously, we can't do this forever. At some point, we're not going to have enough voltage, and Unigine Heaven is just going to crash on us or start artifacting like crazy. But one of the steps with what we're trying to do here is to find that breaking point. So I'm going to carry on at 900 millivolts this time, and it's going to be at, let's see, what's this point at now? 1830. So Afterburner brought it down a little bit to 1830. So 1830 at 900 millivolts. I'm going to go ahead and apply. Flattens the curve. Now we're at 1785 megahertz. So Afterburner is really trying to tell us, like, hey, look, buddy, you can't run at 1830 megahertz at this low of a voltage. We're gonna bump you down to 1785. That's more reasonable. That's perhaps why we haven't crashed yet. If we tried to bump this up, trying to manually override it to 1830, then we crash, because now we're operating outside of Afterburner's suggested limits, essentially the limits of the graphics card. So now I'm going to revert this before it tanks the whole system. Okay, so the application crashed, completely closed, which is expected. So what this tells me is that we simply don't have enough cooling on the GPU. Even with the two case fans that I put on there temporarily, it's just not enough to cool this thing. So unfortunately, we've just failed our 0 fan PC challenge. I think at this point, I pretty much have no choice but to remount the cooling shroud onto the GPU if we want any chance of actually running this system reasonably. At the very least, we can still shoot for a sort of secondary challenge by getting the GPU fans as quiet as possible, most likely with the help of undervolting, so that we can maybe still get a really silent system by the end of this. All right, the fans are back on the GPU, the unicorn puke has returned, and we are still overheating. 83 to 84 degrees Celsius right now on the GPU core. That's because we don't have any case fans. Just because we slapped some GPU fans on doesn't mean that those fans have fresh intake to pull from. So we're gonna have to work our magic with some undervolting here in hopes of bringing those temps down. So I'm gonna try undervolting by 100 millivolts to start off. Usually I go with smaller increments, but I'm gonna jump ahead. I'm gonna just right out of the gate shoot for 100 millivolts of an undervolt. So going from 1031 to 931, which would probably be right about here. It's 937, sure, we'll try 937 millivolts at 1860. All right, looks like it wants to go to 1859. So we'll do 1859 megahertz at 937 millivolts. Right now, again, we're at 84C. Oh, by the way, I'm gonna hit L to lock that so that Afterburner doesn't try to readjust that. In this way, I'm saying, Afterburner, I know that you're trying to help me out, but I know better than you, and I don't want you to override my commands. So I'm gonna apply that. Now you can see all these points went up to exactly where I specified, and our temperatures have dropped 5 degrees. Let's see just how much further we can take this. Okay, I think I've settled on a pretty good curve here. We're at 1860 megahertz at 900 millivolts. So that's almost a 130 millivolt decrease or undervolt. And look at our temperatures, 73C. We've gone down about 11 degrees Celsius from when we were running at stock. And theoretically, we won't be losing much performance, certainly nothing noticeable to the naked eye. This is the beauty of undervolting. At this point, I'm gonna say we lock this in. And by the way, the actual fan speed of the GPU is currently, it's on auto right now, but it's around 50 to 52. And it's still very, very quiet. It's obviously not silent. You can hear it if you're listening for it, especially if you're only like a foot away, but it's easily one of the quietest systems I've ever put together because there's only 3 fans in it, and those are all on the GPU. So at this point, I'm ready to run our gaming benchmarks, and then we'll circle back with the final results. All right, the results are in. So let's take a look to see how our undervolted GPU did with only its own fans at its disposal and no other active airflow aiding in the process. So here we have the original system that's running fully stock and has all of its fans installed. And then here, of course, is our undervolted system. Both the CPU and the GPU have been undervolted here, and our GPU fans are the only fans in the entire system. So starting with Ashes of the Singularity, I tested 3 AAA titles. Our stock system with all the fans scored 93 FPS on average and a 1% low of 49 FPS with a max temp of 71C. Compare that to our undervolted semi-fanless system and we got an average FPS of 89, a 1% low of 47, and a max temperature of 70C. So right off the bat, you can see that our frame rate did decrease. It did drop both in the average and the 1% lows, but by a very small amount. As far as average FPS goes, I think we only incurred about a 4.3% performance hit, which is really not noticeable in game whatsoever. And our temperature was actually a degree cooler, although I'd chalk that up to margin of error. The important thing here is that we didn't really lose too much performance and our temperature stayed relatively the same. We saw some similarities and some differences in Far Cry 5, with the stock system scoring 112 FPS on average and a 1% low of 87 FPS versus 108 FPS on average with the undervolted system and 80 FPS with our 1% lows. So our average frame rates hardly decreased, somewhere between 2 and 3%, which is next to nothing, although our 1% lows did take a slightly bigger hit. And here we can also see that our undervolted system did run quite a bit warmer due to having 0 airflow in the case apart from the GPU fans. Finally, in Shadow of the Tomb Raider, we saw very little change here across the board, going from 78 FPS on average with the stock system to 76 FPS with the undervolted rig, and 1% lows dropped slightly as well, going from 46 to 44 FPS our temperatures are more or less the same between both systems. So the main takeaway here is that by simply undervolting our CPU and GPU, we were able to remove almost all of our fans and still pull off very similar gaming performance and thermal performance as an identical system running stock with all of its fans included. And that's why if you're using components that respond positively to it, undervolting is pretty darn awesome. The final question here is, was it worth removing nearly all of our fans and undervolting the whole system to get the results we saw today? No, in this particular scenario, removing the fans from this system was kind of pointless because this rig was already super quiet to begin with all of its fans installed. There was really no reason to remove them in the first place. We were simply trying to figure out if we could. But just because you can do something doesn't mean you should. And besides, we weren't actually able to do that. We had to add the GPU fans at the end of the day because it was overheating. That being said, there probably is a very niche use case for needing to run a completely fanless system. But for the vast majority of users, the average person is not going to find it practical enough to try to do what we did today. Undervolting is a different story though, because it can help your system stay cooler, quieter, and more efficient without taking a huge performance hit. Of course, you would only need to do this if you needed to do this. If you already have decent cooling and high quality fans in your system, things like that, it's probably already running cool and quiet enough. But if that's not an option, or if let's say you're building inside of a small form factor system where cooling support is limited, then undervolting is a very viable option that can really aid in all those areas. At the end of the day, I think most of us would have been able to predict the outcome of this little experiment, but there's also something to be said about being able to prove a theory, regardless of how obvious it might seem, with hard data, and being able to definitively say this does or does not work. But that's all I got for now, guys. Thank you so much for watching this one. You know the drill. Toss a like on this video if you enjoyed it, and get subscribed for more tech content on the way. I will see you guys in the next video.